All right, the normal distribution. When you think the normal distribution, you need to be thinking about the mean and the standard deviation. And in order to really think about how this all fits together, think empirical rule. So when you have the normal distribution, we've got kind of the bell-shaped curve. Pretend that is perfectly symmetrical. Remember that the mean cuts right through the middle, and that right there is our mean. The standard deviation, right, goes on either direction. So here's the mean plus the standard deviation. Here's the mean minus the standard deviation. So the normal distribution means we are normally distributed, meaning we have the bell-shaped curve. And to use that and really play with it in terms of probability, we've got to have the mean and the standard deviation. Now, what types of things are likely to be normally distributed? Well, generally it's things that are similar. So, a couple of examples. Weights of 50 newborn babies from the same hospital, because they're in the same general area, so they're going to have the same basic life. Well, not necessarily, but if you think about 50 newborns in the same hospital versus 50 newborns in 50 different countries, that's totally different, right? So we're talking about things that are in a similar location. Also, heights of redwoods in a California park. If you go to one park and you look at all the trees in that one park, or 50 trees or however many trees, they're in the same area. They're getting the same weather, right? Same amount of rain, wind, whatever. They're going to have the same outside effects. Not 50 trees in 50 different states, right? A tree in Southern California is going to be very different than a tree in North Dakota, right? The atmospheres are different, and that kind of thing. So we're talking about similar things are more likely to be normally distributed, but that doesn't mean they necessarily are. They just have a better chance.